Welcome to Getting to Know Google SecOps. I'm John Stoner, and today we're going to introduce another regular expression function. This one allows us to capture strings within fields that can be used elsewhere in our searches and YARA-L rules. re.capture provides us a way to extract a portion of a value within a field and compare that portion to another value or write the captured value to a placeholder or outcome variable that can be used elsewhere. The syntax for re.capture will generally be a field name followed by the expression that we are trying to match, and within that expression there will be a parenthesis that will denote what is being captured. For those not very familiar with this, don't worry, we'll walk through an example. Like other functions, the capture value can be nested and used with other functions. Let's take a look at this in action. Our example will look at process launch events, and we will group our detections by principal hostname over a 5-minute window. We will start by using the re.regex command in the target process command line field, and we'll look through the folder structure to find who am I before .exe. By the way, I use Gemini to generate the RE2 here, so don't feel like you need to be a regex ninja or anything. In the outcome section, we are outputting everything after the last folder to the command line outcome variable. When we test our rule, we can see who am I commands, but we still maintain the command switches in the output. That's one example of using re.capture. Here's another. This time we are working with PowerShell data, and we have encoded PowerShell in our command lines. Let's separate the encoded PowerShell from the rest of the command line. We have a few lines using re.regex to focus on a subset of events, and then we have a placeholder variable called encoded value that we are going to use when we find values within the target process command line field that matches our regex. These values will contain -enc or ec or -en or -encoded command, followed by some non-word characters, and then capture everything after that that is non-white space. I'm sure folks can tighten this regex up further as needed. Anyway, we can take that placeholder variable, encoded value, and use it in the outcome section with the aggregate function array_distinct to output those values within our detection. When we test our detection, we can see our outcome variable with the encoded PowerShell in it. Notice how in our first example, we did the capture within the outcome variable as a nested function, and in the second example, we used a placeholder variable in the events section for the capture, and then outputted it in the outcome section. Both methods will work. It's really a question if you intend to do any additional manipulation on the values in the events section before outputting it. I'm sure you're looking at this and thinking, great, I have a field with encoded PowerShell. Now what? Well, perhaps you could run some automation on that value. Copy and paste it into your favorite decoding tool. I like CyberChef. Or you can check back next time where we'll use another function called strings.base64_decode to see the next step of our journey. As you can see, re.capture allows us to capture a portion of a value that can be used for comparison or applied elsewhere in our rule or search. The syntax contains both the field and the regex expression, and remember that parentheses are used to capture the portion of the string you want to write to a variable or compare it to another string. Finally, these values can be used elsewhere once captured, or we can nest re.capture with other functions. In fact, in our next video, we'll do just that. If you want to learn more about Google SecOps, check out my blog series called New to Google SecOps for more handy tips. We have a number of community YARA-L detections at our GitHub site and are continually adding more. And don't forget to engage the security community at secopscommunity.com.